Hi guys, welcome everyone. Today's topic I'm doing Cambridge O Levels at Maths 4037 past papers. The topic is Indices, SURDS and Logarithm. I have made about 6 videos the topic to cover this Indices, SURDS and Logarithm from the additional mathematics book. Today's video can be a little bit lengthy and I would like to show you something like which type of questions I have selected here. Like this is the first question and this question. Like we are having so many questions from this topic because there are 3 topics here: indices, surds and logarithm, and we are having so many questions. So the first is the question is from June 2010, paper 2, question number 4. Okay, this is one of the simple question. I would like to start from here, and let's see how many questions we can do today. Okay, this is radical. Surds are given. The diagram shows a right angle triangle ABC in which the length of the AB is 16 upon under root 2. This is A. You can now see this A is here. Okay, A is here. This is given, and BC is given. Angle BCA is theta. This is not theta, this is Q. Like this is theta actually. The actual paper is having theta here. Okay, this theta is here. Okay, this theta is given here. Find tan Q. This is actually theta. Tan theta. We need to find the first part. The first is we require tan theta to find. Okay. In terms of this, where A and B are integers. Remember, there is no under root in the denominator, so it means we have to remove the denominator if we find. Okay. Tan theta. What is the tan theta ratio? According to SOHCAHTOA, the tan is opposite upon adjacent. So what we can write? Tan theta is 16 under root 2 divided by 7 under root 3. This is opposite upon adjacent. I have written tan theta, the ratio. Okay. Now what we have to do, we have to write like this. So before that, I will convert this 6 upon under root 2. When I write here multiply, because this here is 1. So even you can write like this. Okay, to make your work easy, you can write like this. And after that you can write under root 2 and multiply and 1 upon 7 under root 3. Okay. The radical, we are having the under root in the denominator. Okay, let me simplify first little bit. That will be here I am solving. Tan theta is 16 upon 7, and this under root 3 under root 2 will become under root 6. Okay, what is here? There is in the requirement there is no radical, there is no under root. So what we have to do here, I have to remove this under root. We don't need to remove 7, so it means just under root 6 multiply and under root 6, just you need to multiply. And please, while doing this integers like radical, don't use calculator. You can use calculator, but examination should know each and every step. Okay, this under root 6 is only 6, so it means you have 7 into 6 only. So it means there is no radical sign, there is no under root in the denominator. Okay, this here you can write 16 under root and 6. After this you can use a calculator, there is no problem. Like here, like if you put all the value in calculator, you will get the answer. Otherwise 2 times 3 is 6 and 2 times 8 is 16. So the final answer is 8 under root 6 divided by 21, and that's your answer. And A and B are integers, means A and B are not in decimal, where you can A is 8 and B is 21. We don't need to show that A and B. Okay, to find AC, we have to use Pythagoras theorem. The hypotenuse square is equals to adjacent square plus opposite square. The hypotenuse is x square. Adjacent is 7 under root 3. whole square, and opposite is 16 upon under root 2 whole square, and by using this we can find the value by calculation. X square is equals to, when you use this is coming I think so 147, and this will become 128. When you simplify you will write the root, and the final answer is coming I think so 275 is here, and the root is coming 5 under root 11 and units. Okay, the next question is November 2004 paper 2 question number 2. In this question we have to move from the right hand side. What we can do here, like 13 divided by 4 plus under root 3. To rationalize it, because we don't need any denominator here, so rationalize means we have to multiply and divide with negative sign. This negative sign, and this is also, now we have to apply in the denominator the formula a square minus b square, difference of 2 square. This we can write 13 times 4 minus under root 3. This is 13, before multiply this 13, just wait for the result from the denominator, maybe that will cancel with 13. It is sometimes possible. 14 square is 16 minus 3 under root square is only 3, and that's becoming 13. Okay, that's good. When this is 13, when this is 13 and 13 cancel out, your result is coming 4 minus under root 3. Okay, but one thing, this is not equal to this because we need square root. This is very, like, this is not easy question, this is little bit difficult. So in this situation we will not leave our answer here. What we can do here, like 4 minus under root 3, I want to make under root because I want to get the answer in the root form, and root form means I cannot apply the root in one because this is not an equation. So for this purpose I have to do one thing. What? I will use the bracket and I will write square. That means the square and square root cancel each other and there is no problem, there is no effect. It means we can write it, but as we required under root in the given question, so we have substituted, like we have written square root and square. Now we can expand, the square root will remain there, we don't need to change it, but we have to expand this by using perfect square formula. Under root 3 plus under root 3 whole square, and final answer is coming 16 minus 8 under root 3 and only plus, root cancels 3, and final answer will be 16 minus 3 is 13 and minus 8 under root 3. Now that's your result. Now you can compare with this and this. The value of a is, because find without using calculator, like the value of a and b. So the a is 13 and the b is plus and this is minus, so b is negative 8, and we have done it. This is one of the important question, like when we have to make some square and square. This is the same example I want to give here. Suppose you have 2 and I want to make it 4. So how can you make it 4? You can write under root 4. That means under root and 2 square, and that is becoming 4. And like this was a question like this, 4 and 2. How can you make it 4? Because the same basis, like this 4 and 4 same, the answer will be 1. So for this purpose I have to write under root and 4, and this under root means 1 upon 2, and this 1 upon 2 become what? The coefficient, and this answer is coming 1 upon 2. Okay, moving to next question. Okay, this question I have seen about 3 questions in 15-year career, like 15 years. This type of question students have so much problem without using calculator. This is a lengthy question. I have two questions like this. One is here and second is, yeah, this is the same. We can use any one of the, like this is, what was actually this under root, and here is also under root, and here is also the root. This root is there. Okay, this x is not with the root, I mean inside the root. For the roots of the quadratic equation, this is also something like with the quadratic equation chapter 4, but I would like to explain something without using calculator. Show that this, okay, in this situation the roots means when you want to find roots, the y will be always equals to 0, and that is equal to 0 here, and roots are the value results of x. So now can you make the factors? Not possible. So for this purpose I have to use quadratic formula. Okay, quadratic formula, this is one of the lengthy question here. X equals to minus b plus minus under root b square minus 4ac divided by 2a. I will put the values here. Okay, b is minus and minus under root 20. Be careful, like there is a possibility of mistake here. Plus minus under root minus 20 square minus 4a is 1, c is 2 divided by 2, and this is 1. Okay, minus minus is plus only under root 20. Plus minus, you can use here calculator. Minus square is positive 20. 20 minus 4 to the 8, and 20 minus 8 is 12. So you can write 12 here and divided by 2. X is equals to 20 factors. The 20 factors are 2 times 10, 2 times 5, and then 5. So 2 under root 5 is your first factor, like factor for this, and plus minus 12, you know, 3, 3, 3, 4, 12, and sorry, 3, 2 and 2. So 2 under root 3 divided by 2. This 2 is common and with cancel out, so final answer will be, I am writing here, plus minus this. When I take 2 common, this 2 and 2 both are cancelled out with this. I am writing the direct answer. X is equals to under root 5 plus minus under root 3. Okay, these are the roots. How many roots are there? Plus minus, there are 2 roots. Okay, is given the roots of the quadratic equations are c and d. Without using calculator, find the value c. Okay, c is 1 is c under root 5 plus under root 3. This is one of the most, I think it's the most important question. And the d is under root 5 minus under root 3. Now what is required? 1 upon c plus 1 upon d. Okay, 1 upon c plus 1 upon d, we have to prove that is equals to under root 5. We have to show that. Okay, show that 1 upon under root 5, put the value, plus 1 upon under root 5 minus under root 3. I am putting the value. Okay, after putting the value, take the LCM. LCM will be definitely both the values because nothing is common. Okay, this under root 5 minus under root 3 plus this will come here. Okay, this will come here, and this will move here. Like up, I have taken the LCM. This is plus under root 3. This 3 under root and negative positive cancel. The result is 2 under root 5. Okay, I'm writing here 2 under root 5, and you can use difference of 2 square formula. 5 square minus under root 3 square. Root cancel with this 5 under root, and this 2 under root 5 divided by, this is only 5, this is only 3. The result is coming only 2, and 2 to cancel out, and under root 5, and we have shown. That's good. It's a very important question, and we have the same type of question. There is no question in the book like this, so that's why please practice this and do this part. I just want to show you this June 7 paper 2 question number 3. Please do it. And I am moving to the next category of the same topic, that is, okay, we are having, okay, the first question is from November 2004, paper 1, question number 3. This is one type of simultaneous equations. Like I would like to do a little bit fast. 8, 2 and 64. Can we make all the bases of like 2 cube? First equation, I'm using the first equation. 2 cube is mean 3x divided by 2 power y is equals to 2 power 6 is 64. Okay, then we can make two same bases and division power will minus. Okay, then after comparing the bases, you can equate the powers, and that is your first equation. Okay, moving to second, you can make y the subject, like y is equals to, when y positive, shift right, 3x minus 6 is up to you. Okay, second equation is 3 power, equation number 2, 3 power 4x. You can write, multiply by 1, power is whatever is 1, and 9 will become 3 power 2. And the whole power is y minus 1, and this will become 3 power 4. All the bases of 3. Now, we can write single base 3 power 4x, and minus 2 times y is 2y. So that means it will become negative 2y, and 2 times 1 is 2, negative 1. And when I move up, this is becoming plus 2, and by that we can have, we can now compare the powers. That's 4x plus minus 2y plus 2 is equals to 4, and when I move here is equals to 2, and so on. This equation and this equation, let's do it simultaneous. Thank you so much. We can, and then you can have the answer after doing the simultaneous equations. Okay, next question. Okay, we have this type of question. First of all, my target is not this part, but as we are having the same year and question 7 and 7b, let's do it. This is a given to substitute u is equals to 5 power x. In this question, we have to break this like we have done in 3.4 and 3.5. 5x into 5 power 1. We have to divide because power is 5x plus 1, so we can divide. Okay, is equals to 8 plus 4. This 5 power x, negative x, when it moves down, this become positive. Now, wherever we have 5 power x, we can substitute u. So, u is equals to, or u multiplied by 5 is equals to 8 plus 4 upon u. Sorry, this is u, and I have written by u. 5u is equals to 8 plus, like what you can do here, you can shift minus 8 in left hand side, is better because we don't need to take the LCM. This u will multiply with there. This is 5u square minus 8u and is equals to 4, and this equals to 4 when I shift to left hand side is minus 4 equal to 0. Okay, factors 5 4s are 20 minus to get 8. So 20 means you can write minus 10u and plus 2u minus 4. Common is 5u, u minus 2, nothing, 2 is common, u minus 2 equals to 0. Okay, 5u plus 2 and u minus 2, we are having two results. So u is equals to minus 2 upon 5 and u is equals to 2. As we are finding the value of x, so it means we have to apply, since I have already discussed in Like you can see, if you are not seen my videos from 3.1 to 3.6, there are 6 videos to support this past papers. Please watch that videos. Okay, u is 5 power x is equals to minus 2 power 5. This is not possible because the one base is negative, so this is not possible, but we can move here. 5 power x is equals to 2. Okay, now we have to make the same basis, but can you make the same basis? No. So we have to apply LG both the sides. When we have same basis, we can compare the powers. Okay, power law, x will become the coefficient, and this is LG2. And finally, x is equals to LG2 divided by LG5. And you can get the answer by calculation. And again, I am telling you, in calculator, the LOG is your LG. Please. LOG divided by LG5, and that's your answer. And please give the answer in three significant figures. 4306 means 1, and that's your answer. Next part. Okay, we have also given that this second part, given that p minus q and this express p. Okay, I'm solving this. Okay, that's fine. Okay, here this log p minus q and log p, can you make the same single logarithm here? How can you make single logarithm? Log minus means p upon q, p upon q. Now in left hand side you have log p minus q. It means this and this log same, so we can compare which part? We can compare this and this. So what's the final answer? The final answer, sorry, the space is not enough. I want to move here. So p minus q is equals to p upon q. Express p in terms of q. Okay, p in terms of q, I have to multiply first. Pq minus q square is equals to p. Okay, I want to write p as a subject, so p is 2 times. Whenever the subject is 2 times, we have to write both the subjects in one side, like left hand side, and this q will become q square positive. Now take p common. When you take p common, this is q square, and finally p is coming q square upon q minus 1, and we have done it, right? The next past paper question is same as we have done. November 2007, paper 1, question number 7, part 1. 2 power x, y, or u is equals to 2 power x, so it means u square will be 2 power 2x. This is the easiest way to write first. Okay, now what we can do, this 2 power 2x will become y square is equals to, this you can break, 2x into 2 power 2 plus 5, and this is becoming what? Y, because this is, so y square is equals to 4y plus 15. I can like do the question slowly, but actually the video will become so lengthy, that's why I sometimes leave the steps. Multiply to get 5 and minus to get 4 means your factors are 5y plus y minus 5 equals to 0, and when we take common in first 2 and second 2, this is your result. Nothing is common, 1, and so y minus 5, y plus 1, so y is equals to 5 and y is equals to minus 1. Remember, we are finding x, so since u is equals to 2 power x, u is 5 and u power is equals to 2 power x, and u is minus 1, and this is not possible because the negative sign, as we have done here. LG5 is equals to LG 2 power x, so LG5 is equals to x LG2. This LG2 will divide and you will get the value of x. You have to solve it. Thank you. This B part is same, so I'm not doing, but you try this please to do that. Now I am moving to this question solving, writing the single logarithm, and equal sign is there. In right hand side there are two terms, in left hand side we are having also two terms. Can we write the single logarithm? Okay, single means there will be no coefficient with LG. Oh yeah, 2 is there. I have to move 2 first. 2 will become the power, as we know, the power law. So LG 5 square is equals to, okay, 2, I want to write here LG. When I write LG, I have to write 10 because LG 10 is 1 and there is no problem. And this 2 will become the power. This I have explained in my 6 videos about this topic. You should watch before this solving past papers question. There I have explained all these things, explanation. Okay, single logarithm LG once 7x minus 3. When you have plus, you have to multiply with 5 square is 25. Okay, here I am writing LG. This 2 will become the power. So I can remove from here, write 2 here. So it means 10 is square is 100 and plus means we have to multiply with x plus 3. In this situation, when LG, we have single logarithm, both the sides, then we can compare 7x minus 3 multiplied by 25 and 100 into x plus 3, and we can do the calculation. But one thing, please, I'm doing this 25 times 1, 25 times 4. I want to make my work easy. I can, because 25 will divide here, so that will cancel. Now this is easiest now. 4x plus 12, and you can get the answer of x, and 4x minus 7x is 3x, and 12 is 15, and x is equals to 15 upon 3 is 5, and we have done it. Okay, next question. Okay, this is the same type of question. We are having 2 terms in right hand side and 2 terms in left hand side. So I will not solve the whole question, but I can write, there is this coefficient should move here, and 1 I want to write what? LG10, yes? Okay. Plus LG3 square is equals to this 1, I will write LG10. Suppose we have log 2 something, log 2 something, log 2 something, so I will write here log 2 2. Now whatever base is required, I have to write that. And 4x plus 12. Now after this, LG ones 5x plus 10 into 3 square is 9, this 9. LG ones 10 into 4x plus 12, and by writing, comparing this, log cancel out and you can simplify and get the answer. Now second part, this second part is something we have to solve it. Second part is like easiest part. 3, you can write 3 power 2, and 2y is already there. So there is one possibility the students makes a mistake here. I would like to show you which mistake. Please do not do that mistake. I have seen number of students doing the same mistake, and I want to show you where the students will do the mistake. Okay, 3 power 3 and the whole power is y minus 2. Okay, what are the mistakes? 3 power, this will become 2 times 2 is 4y. 3 power 7 minus y is equals to 3 power 4y plus 3, and 3 power is 3y minus 6. What the students do? They cancel this 3. No, this is false. This is wrong. Please don't cancel 3. What you have to do, you have, this is wrong. So please, I am not cancelling it. This is wrong. This 3 will move up. 3 power 4y minus 7 and plus y, this is y, is equals to 3 4y plus 3, and this 3y will become minus 3y, and this 6 will become plus 6. Now you can compare the powers, and then you can simplify. 4y and y is 5y minus 7, 4y and 3y is only y, and then 9, and this left hand side is 4y is equals to 9 plus 7 is 16, and y is equals to 4, 16 upon 4 is 4, and that's your answer, and we have done it. Okay, here, this part, second, this is called change of base law. This is like, these are the questions that are like, I found these are the difficult questions. Change of base law and how you can use it. Okay, the first is very simple. I hope that you will try yourself. LG10 you can write here. This 4y and 2y, like, bases are different. Okay, I have already explained change of base law. The first is like, whenever you have log AB, I have already done like explained everything, but because of, okay, this, the first change of base law is when you require the third base. Third base means when you require x, third base, you write x and b upon a. But when you want interchange of base means when you want to make this as a base, a base is there, you want to make b as a base. So what you can write, this is called b, and this will here, and this is 1. This is interchange of base. There are two possibilities, third base and interchange of base. Okay, what I have to do here, this is 4y and this is base 2. What should I do here, like this situation, that can I make this 4 as base 2 because 2y is there? Okay, yeah, I think so is better. What I have to do, I will use third base formula, this one. I want to make 2 as a base. When I will make 2 as a base, what will happen? Listen, log, this is y, this is 4, and your base is 2. Because of this, what are the benefits? This log 2y is equals to 12. We have already this log 2y and log 2y. We can suppose this log 2y is equals to you can suppose x. Okay, x upon, I have supposed what, let log 2y is equals to x. I have supposed there to make my work easy. This log 2, what I can write, 2 square plus, this is x is equal to 12. This 2 square means this 2 will become the coefficient, and this is equals to what, 1. So the final is x upon 2 plus x is equals to 12. Okay, now when you add it, there is 1, then 2, and this is 3 upon 2x is equals to 12. X is equals to 3, 4 is 8, I think so. 2 is 8. But this is not a result. I have to apply this here, since, and put the value here. Log 2y is equals to 8. Now because question is given y, so 2 power 8 is equals to y, and y is equals to 2 power 8. You can even write, that's up to you. That's right. Change of base are very important part, and I'm moving to the next part. Okay, this question, when the base is 3 and the base is x, again, what do you want to do here? Base is x, y, and base is 3. Can I make, it's up to you, because it's an interchange. For interchange, the formula is 1 upon log y3. Interchange, change of base, this 4 will become, oh, don't write it because we have to substitute the value. So you can suppose let log y3 is equals to x. So now this is 1 upon x plus 4x is equals to 4. Now what you have to do, take the LCM or multiply the whole equation by x. This is the easiest way. The LCM multiply the whole equation. You don't need to show have the denominator. This automatically x cancel 1. This is the method actually. You can use it. This is 4x. The whole equation will multiply with the x. This is the shortest method. So the 4x squared minus 4x plus 1 is equals to 0. And then you can move to the next part. That's look like a perfect square formula. 2x plus minus 2. This is mathematics perfect square formula. So yes, exactly the 2x plus minus 1 whole square equals to 0. 2x minus 1 equal to 0. X is equals to 1 upon 2. And please, this is not a result. Apply since what we have supposed log y3 is equals to x, and log y and x is 1 upon 2. So what we can write, y power 1 upon 2 is equals to 3, and y is equals to under root 3, and we have done it. Next part. These are change of base law. Yes, most important. November 2003, paper 2, question number 3. Base 2, base 4. This is like I would advise to make. You can make better to base 4 here. There is no, I think so both are possible for me. I can solve both the, I can make it base 4 or I can make it base 2. There is no problem. Okay, when I want to make it base 4, I know, remember I discussed with you, like when you have base 4 and 2 here, what you can do? You can write root and square. Yes? Okay. This I want to make base 4. This is log and log. This is x upon 2, and the base is 4 and 4. 4x, and then you have here minus log 4x minus 4. Then here you can write log 4 and 4. This will become, you can write, can we write this is under root 4, and this under root 4 will become 1 upon 2. Yes. Okay, I'm solving all the parts here. Log 4x divided by, this will become 1 upon 2, so 1 upon 2, and log 4 is equals to 1. And this will become log 4 and 4 square. This is equals to 1. Sorry. This is equals to 1. This is equals to 1. So the finally what I have to do, this 1 upon 2 will become above, move up is 2. And this is log 4 square is 16. Now you can write this 2, you can move from here, and then you can write single log. Log 4 x square minus means divided by x minus 4 is equals to log 4 16. This is cancel out. X square upon x minus 4 is equals to 16. X square is equals to 16x minus 64, and then you can have, and then you can simplify, get the value of x, and that's your answer. This is a way. I mean, there is also one more one other method before completing this question. This, the first part is log 3, and yes, this is important part. is equals to, I can write here not LG10, I will write log 3 and 3, because what I want here, I have to write the same base with log. A single log I am writing here, this 2 will become the coefficient. Sorry, I am leaving the steps because I have the option, but you don't. In your copy you have to write 3 square is 9 into 3x minus 11, and this cancel out, and the final you can write 2x plus 1 is equals to 9 into 3x minus 11, and then you can simplify now, please. Okay, second part is again the base, change of base law. I will just write in short. I can make this base of 2 is better because 2y is there. I can write log third base. Third base means the base is 4, the third base is 2. Then this base is 2, then I can write plus log 2y is equals to 9. Now I can suppose this and this is equals to x. So x upon this will become 2 square, and 2 square means this 2 will become the coefficient, and by this way this will become what? Log 2 is 1, and x upon 2 plus x is equals to 9. I want to x and 3 upon 2x is equals to 9, x is equals to 3 and 3 to the 6 is your result, but you have to apply what we have suppose log, what we have done here, what apply since log 2y is equal to log 2y is equal to x, and x is 6. I have applied since here, and 2 power 6 is equals to y, and that's your result. Okay, the next category is about this June 2007 paper 2 question number 5. This type of questions are also coming in logarithms or indices. The first part, express this as a base of 2, power of 2. Power of 2 means you have to make 2 and something power, please, not 2 as a power, 2 with power of something. This is your requirement. Okay, 1 upon 32 you can write 2 power 5. Okay, then you can write 1 upon 2 power 5 upon 2, and then you can write this, move up, you can write 2 power minus 5 upon 2, and that's your result. This is the way this you have to write. Now this as a power of 2 means your base will be 2 and power can be anything. This is the way, please. 64 you can write 2 power 6, and the whole power is 1 upon x. Then you can write 2 power is 6 upon x, and that's it. This situation hence means we have to use the result of this. The result of 64 is here, and the result of under root 32 is here. I have to use the same result. This is the way actually. So what I have to do here I have to use I'm solving here. I have to use 2 power 6 upon x. 2 power x is already there. 1 upon, okay, the 1 upon 32, the whole value is this, so I will not write, this is good. The 1 upon 32 is whole value is this. I can use this value, is better to use 1 upon 2 power 5 upon 2, or you can write 2 power minus 5 upon 2, there is no problem. This 2 will move up. 6 upon x minus x is equals to 2 power minus 5 upon 2. This is cancel out, and you can simplify. 6 upon x, I will write 6 upon x minus x is equals to minus 5 upon 2. 1 is there, take the LCM. LCM is 6. And you can write 6 minus x square is equals to minus 5 upon 2. Do the cross multiplication. 12 minus 2x square is equals to minus 5x, and 2x square, I want to make it positive, minus 5x, and minus 12 is equals to 0, and so on. You can just work on it. But this, what, 2 times is 24, 24 multiply to get 24 and minus to get 5, 24, yes, I think so, 8 and 3, yes, 2x square, 8 and plus 3 minus 12, and so on. You can please check it out because we have to get the answer now. This type of questions I really like. Log p x is 9, log p y is 6, find p under root x. Okay, this power of x is 1 upon 2, so you can write 1 upon 2 log p only x, and this p x is 9, so 1 upon 2 into 9 is 4.5. you can write. Yes, 9 and 9 upon 2 is okay. This log, there are, like, what you can do here, there are many possibilities for this part, but I will do only one part. This minus 1, this minus 1 will become the coefficient, minus 1 log px, and that is equals to px is equals to 9, so minus 1 into 9 is minus 9. That we have done. When we have p, we can write log p x and plus product log. P is 9 and y is 6, and answer is coming 15, and we have done it. This is what? Base is y. There is no base y. The base is only p. It means the given question is having p base. So what we can do, we can make the third base. The third base is what? The third base, I have to consider the base of p, which is given. And what we can write? X upon y. X upon y. Log px is 9, and this is 6, and 3 upon 2 is 1.5, and we have done it. This type of questions are looks like simple, but sometimes it creates problem. This is the same question. What we can write? Log p x square minus log py. This 2 will become the coefficient here. Now you can put the value px and py from the given question. Yes, this is same I have done. Like, I want to make what? Log third base, and third base is, this is x upon y, and the third base is p. This is the repetition of the question. Okay, this question I remember in my class students had the problem, but okay, 2 power z. 2 power z means what we can do here. Some students have written like the value, the whole z, writing here, but actually I want to write 2 power something. This is 2, so can you make this 5 is like 2? Z is equals to 5 log 2 and 2 is 1. Okay, then this 5 will become the power. Can I remove please? 5. Okay, single log 2 square, 2 power 5 is 32 into yes, 3. Then this 2, index form 2 power z is equals to what? 32, 3 to the 6, and 3 to the 96, and that's your answer. This is also the way the students, you can do it like this. The C part is like 512 power is under root, so we can write 2 power 9, the whole power is 1 upon 2. Okay, 2 power is 9 upon 2, but one thing, actually I want to make this 2 as a 4, so when I write 4, I have to make the root, and the whole power is already 9 upon 2. This 1 upon 2, again I want, like, can I make it 4 power 1 upon 2 and 9 upon 2 multiply is 4 power is 9 upon 4, and that's your answer. And I mean, this is the way that you can give. This is very good question. When you do this question, please write the answer in my comment. I want to see especially this part. This is, I think so I should give a challenge. When you will do this question, I will definitely solve your required paper, or whatever the question you want to like get solved, I will solve it. Thank you so much, and I hope that this the whole paper took a lot of time to complete, and I hope that you understood. Thank you so much. Thank you so much, and have a nice day.